Example 5-5 is about a concrete trapezoidal channel with a Manning constant of 0.013 with a bottom width of 5 meters and bed slope of 0.1%. The sidewall slope is 2 horizontal to 1 vertical, and it carries a discharge of 15 cubic meter per second. So at the downstream end, the spillway raised the water depth to 5 meters. So automatically, we need to calculate normal depths and critical depths to determine the classification. So the question asks to determine the water level at 1 kilometer and 4 kilometers upstream of the control section. So there are two approaches to determine the distance. We can either use the direct step methods, which we solve two examples, example 5-4 and 5-3. So I refer all of you to watch those videos. And now we are going to use the standard step methods to see how we can determine the depth at location. So direct step method is very straightforward, and you can determine the distance very accurately. But the standard step methods requires more computation, but can be used for non-prismatic channel as well. Okay, so the first step, we need to calculate the normal depth. So we use Manning's equation, Q equal to A over N, R to the power of 2/3 is to the power of 1/2. So we put the geometry of the trapezoidal channel, and then we calculate critical depth using the Froude equation. So Froude square is equal to Q squared B divided by GA to the power of 3 equal to 1. So we are going to use Excel. So in this example, first we start to define normal depth. So this charge is 15. So I start with 1 to see. So I put 1 for YN. So it gives me a discharge of 17. So it's overestimated. I need to reduce the depth, maybe 0.9. So it's going to be between 0.9 and 1. So I try 0.95, maybe 0.94, less 0.93. Okay, 0.935. Okay, 0.934. Yeah, we are close. Okay, so 15.08 versus 15. So 3 digits after decimal point is good enough. For critical depth, I start 1. So Froude number is less than 1. Maybe I need to reduce the depth to getting close to the critical flow. So maybe 0.9, maybe 0.5. So 0.7, okay, 0.75. Okay, we are very close. 0.76, 0.755. Okay, we are close. You see, it's 0.99. Maybe if I use 0.074, yes. Okay, so now I have normal depth is 93 centimeter, and critical depth is 75 centimeters. So these two numbers determines that the channel is mild. So I'm going to have M1 curve. Now here for standard step methods, I need to develop 15 columns. So the explanation of how to develop these 15 columns are in the textbook. So you can read. So first we start a depth and the distance that we are interested. So at each distance, we do a trial to adjust the required depth. Then we have cross-sectional area for trapezoidal channel. We know that it's B plus my times y. We have weighted parameter. So B plus 2 square root of 1 plus m square times y, depth. Hydraulic radius is area divided by weighted parameter. Velocity, discharge. Make sure that you use a $sign to fix the value of discharge, divide by area. Then we have the elevation. So we have the elevation here, and then energy is Z plus Y plus V squared divided by 2G. And then the frictional slope, which is Q squared times N squared divided by area squared times hydraulic radius to the power of 4/3, so 2/3 squared. And then we calculate head loss, which is distance multiplied by friction, and then energy at the downstream, or at the upstream in this case, is the energy minus energy loss. Okay, and then we have delta H, that's the difference between the energy and the energy that we calculate by estimation of head loss. And the difference should be 0. Okay, so we calculate energy here. That's the previous energy level. And now we are going to, we are going to change the value here. So if I use, yes, if I use the value of 4 meter, then in this case, I can calculate the frictional slope, then the average from previous point to the next point. So you see that each one of those are different points. So this is right at the location of the spillway, and then I have the next point. So 1000. This is the trial. Then I have the next point, and then trial, next point, and trial, next point, and trial. So this is how we can have more than one trial. So here, the calculation up to column 11 is the same. So, but when you do the second trial, you calculate it with the previous point, not with the previous raw. Okay, and then here you calculate the energy loss, and then here the energy loss, and then here you have the previous point, so the energy in the previous point. And then you need to make sure that the difference is close to 0. So in this case, I would say that maybe if I use, so here, it's actually 4 meter. Then in the next step, I use 3 meter as a value. You see, if I change this value to, let's say 3.5, then the difference is significant. Yeah, we need to reduce this difference close to 0. Okay, so you do try and error. You can either use one column to do the try and error, or you can use so many rows to change the values. So for the last one at 4 kilometer, I start 1.078 as a number. I can use 1, for example. And then you see that the difference between the calculation of energy by subtracting the energy from this point to the previous point, or calculating the energy by subtracting the energy loss, is almost half a meter. But I need to change this. So maybe I change it to 1.1. You'll see that the difference decreases. So I need to adjust this value or work in this value until to get, so 1.2, okay, getting close to 0, maybe 1.24. Yes, it's getting negative, but it's very close. So maybe 1.236. And then you'll see that the value is very, very small. So it's close to 0. So this is how we do the calculation by the standard step methods.